All right. It's approaching over a week since my last video upload vlog on the state of the game, and it's coming along quite nicely. I also have a treat for the audience. Many of you who were involved as witnesses to the competition between myself and a fellow IRC slash GitHub user, Hugh Board, who I currently believe goes by Birdnest Stream, um, participated in a contest for the Load Radio Hour where I worked on a game that was supposed to be a clone of the game Tempest, where I decided to put my own spin on it. And I don't have any footage of that particular effort. However, the effort that followed, the idea to unroll the game's polar coordinate system into flatland Cartesian coordinates, resulted in a shoot 'em up. That shoot 'em up is what I'm currently working on now, but in a much better format. The original format was a very bad code base, heavily object oriented, hard to extend, and it got to a point where, um, well, long story short, C++ is a lot easier to work with than C if you're trying to work with data structures and actually manage a ton of different things happening all at once. Um, with that in mind, I've already overlaid the footage of the original game, and that said, I actually took some screencast of me implementing backgrounds. While I wanted to do a video of everything that I've done up to this point, I think it would make a lot more sense, since I'm currently in that headspace, to go over how I implemented the background textures and essentially walk you through that process. I think that's a good target for today. Why not? Let's fucking go. Before we hit play here, so I've recorded a video of my programming session implementing the background textures. So we used ASCII Anima to actually do the screen recording, which is kind of nice because sometimes I might actually pause in the middle of doing shit, right? So we're already planning here, by updating the to do with an item about the background textures themselves. I'm just kind of like thinking through how I'm going to implement this first. The idea that I ultimately settle on is using a separate map to store the background entities and their relative sprites, as well as their transformations, because the first background texture that we're going to load in is actually a moon. And the moon is going to be moving, so that it gives the illusion of the player moving from left to right. So as we're going through this, I've already written a couple function declarations and I've got things loaded in. So we're getting the load moon texture function going here, which is basically just a copy of every other load texture function, which is why I want to consider redoing like how I load textures in, because ultimately this is very redundant and there's probably a more efficient way to go about doing this where I don't have to like repeat these lines so often. SDL texture pointer T equals image load texture path and all of that stuff. There's probably a way to like really wrap this up into like one function so that like every time I want to load a new texture in, I just have to specify the path and the key. Ultimately that's what I want to do. So that's definitely on the agenda, is refactoring this whole thing into a little bit, and that'll probably result in a bit of line reduction as well as just general efficiency and improvements. We're just like specifying the path to the image file and the key. Like I said earlier, that's why I think it should be wrapped up into a function. Um, Now we're in the background.cpp file, bg.cpp, which is essentially just going to be a copy of spawn.cpp, which handles all of the different entity spawn functions. One thing that I haven't talked about that's happened since last time is significant refactoring. Uh, in the previous videos, all the code was sitting in main. Now we actually have separate files for different classes of functions. So normally you would see a lot of object-oriented style organization for a lot of this kind of material, but in this case, using this big entity component system, the only objects that we're really working with are going to be like the standard template library, like data structures such as the unordered map and the vector. So in background.cpp, we've copied over spawn skull, and we're using that as the basis to load our moon sprite into the background sprites map. Places where I'm moving fast, you're going to see me zooming around the screen. I'm probably either looking for something that I have to either edit or copy over. The places where I slow down, you're going to see that I'm actually typing in new things. And that's going to be a general theme throughout this recording. So places where you kind of catch me pausing, it's going to be a good opportunity to like kind of let you know what it is that I'm doing or what it is that I just did. So here we're getting a X and Y because on line 78, I am data casting, I'm typecasting the destination X and the destination Y variables. Those are on line 61 and 62, and those are essentially passed into the transforms because we actually store the transform information as a double, because this gives us the ability to like really fine tune like the XY position and the speed. So like if we want to have something that moves at sub-pixel speed, we're able to do that because we can just store the variable as a double and then data cast it to an int when we actually need to render it to the screen. The reason we need to do that is because all of the SDL functions work with ints for their rectangle data structure, but it also kind of makes sense if you think about it. You can't exactly have half a pixel. So with that in mind, let's continue. So we're undoing the data casting so that we can just have X and Y in the struct that we're passing into the sprites map. We're renaming the function to bg spawn moon, and so every background spawn function is going to have a similar name. And similarly, we'll probably end up being able to refactor some of those spawn functions in the same way that I want to do with the load textures. Of course, just like similar pattern for the other ones. Now, that's something interesting that just happened there. That was something that was generated by Copilot. And one of the reasons that I do enjoy using Copilot is that sometimes it'll just come up with shit on its own. And like in this instance, I don't even have clouds yet. I don't have mountains. I don't have trees. I don't have grass. And, you know, something interesting too is that it also decided that we should also have background spawn functions for the player, the knife, the eyeballs, the coins, and all the other things that we already have, which I find very interesting because like none of those elements are actually in the background. Those are foreground elements, already have their own spawn functions. So why it decided to do that, I'm not sure either. So that's two really interesting things. But for it to come up with these suggestions is incredibly beneficial and a great idea boost whenever you're kind of just slogging through and you don't know exactly what to put in, because you do experience kind of like a mental stretching to be able to have to bounce around between design and implementation, right? So sometimes you might have the entire infrastructure in mind, but not necessarily know exactly what it is to do with it. So in this case, great ideas, but I don't have any of these things yet, so we're going to go and comment a lot of those things out. Next, let's see, what are we doing? Okay, so we threw over load moon texture into the load textures wrapper method, and we are about to throw it into main. Now we actually have a sprites map that we're going to be using. Over in the update file, we are adding our update background sprites. And initially, I realized, it takes me a minute to realize this, but the movement component for the sprite is actually stored in the transform array. So it's going to take me a minute to realize this, but it's not going to be that big of a deal. So we go ahead and create a background entity type.h file, which is going to define the different background types, because we may not necessarily want to do a thing or another with a certain background sprite. So having the ability to separate them out might be useful. I go ahead and kind of operate off of this premise. I think actually what's going to end up happening is that I don't need a background entity type now that I think about it, but we're going to go ahead and just kind of run with it anyway. Eventually I'll go back and get rid of it if I decide that it's not necessary. But we go ahead and create another map to store those. Given an entity ID, we can check what type it is for the background entity. So it's possible we could do some really complicated things. So here I realize that I need the transform as well. So I start off by trying to write a separate lambda. But then I actually decide to take a look at the handle transform function, because I realize I might be able to just pass the background transform array, map into for each and actually use the same lambda. But it turns out that I'm not able to do that, because the original lambda that I wrote is very specific to the transform map. I know this is very complicated, but please bear with me. The transform map function, the lambda function, stores values specifically to that transform map, which is for the foreground entities, which is why I realized, oh crap, I actually have to create a completely separate map for those things. And as it turns out, I also have to create a completely separate handle transform function just for the backgrounds. I'm getting the scaffolding kind of set up here. So we have two new functions, update background transforms and update background animations. None of the textures at the moment have any animations, but as you saw in the old version of the game, we will have candles and things like that. If I can find a way to like actually animate the clouds, that would be kind of nice too. So you see now on line 47, we have a render background sprites. And we go ahead and we throw that into render frame before the drawing of any foreground entities. We add background.cpp to our make file. And then we go and we try to build. It builds, I run the game, and then I start to realize, oh, there's a couple things I need to fix. Everything built and ran, which is great. I've been having a lot of luck getting code to compile like on first try, which says to me that I have kind of like a good developer feedback loop going here. You don't really hear of people getting code to compile on their first try, let alone as often as I do. Not to toot my own horn, but you know what I'm saying? Just like, it's not that hard. That's what she said. Ooh-wee. What a zinger in a code video. God damn. All right, so now I'm playing around with the positions and trying to actually get the moon to start moving. I realize something's up with the X value for some reason. Here I realize, oh wait, the handle transform function doesn't work with the background transform map, and so I'm going to have to actually create a completely separate transform function. It's mostly just a copy of the first one, but I get to kind of remove a lot of the special balance checking and stuff like that. And if I need to handle by like background entity type, I'll be able to do that as well. So here I go and update things so that we update the correct map. And then we just update to point to the correct function. And we just start playing around with the XY now. We double check the texture width because for some reason the X is showing up on the far left, and I realize, oh, we're setting the XY to be to the top right of the screen because of line 78 and the way that the transform system works. Whatever transform value you have in that particular part of the map, you're going to end up having like an additional check that originally I had it set up so that it was supposed to be spawning at the top right, but whatever value you have for that ID in the background transforms map gets copied over to the sprite's destination, which this is actually getting overwritten. So all we have to do to fix that is copy that X value into dest X and make sure that the Y is also the same value. Now that we actually have that going, I start playing around with smaller VX values for the moon. I decide everything works, and I go ahead and take a look at all the code that I've written, and now it's time to commit. We've added background sprite management and our first background entity, the moon. Fucking awesome. We go and update the to-do, mark off a couple things, and I write down a couple notes that I don't want to forget that would be really nice to have in the game, such as enemy grazed and bullet grazed. And one of the ideas is that, it's going to be kind of like a slog to see how long you can play the game, how many things can actually get spawned on the screen before shit hits the fan. Now is the time to actually show you where the game is at currently. Okay, I was late getting this started recording, but let's go. So, as you can see, Skull is red. If I press A, he becomes green. If I press A again, he becomes blue. I don't have any plans immediately for this mechanic, but I was playing around with a texture coloring function in SDL, and it's kind of fun to play with. Like, there's a lot of possibility for spawning lots of different colored entities. Draw once, render many times, right? So as you can see, we've got bats instead of eyeballs now as a bit upgrade. The knives, unlike in the original game, actually have a angular rotation by default. I don't know if this is going to be how it is forever. The coins you can see are yellow, and they may or may not stay yellow. I'm actually thinking of trying to like do a little soul shard type pickup. Might be a little bit more appropriate. The moon is moving quite nicely. This is actually what we just showed you how we went about the process of implementing in the current engine. The current engine because it is current, and I'm thinking about putting the old code back out up on GitHub. It's got a Windows build for it. The version that you actually saw me run was running entirely in Wine here on Linux. And a couple new things that I haven't gotten to talk about since the last update. Every time you collect coins, you collect 5 coins currently. On the right hand side of the screen, you just saw one spawn up, a little floating scroll here, just a sheet of paper. But at the moment, the sheet of paper will either give you a cooldown reduction on how often you can throw your knives, and it can also increase the size of the knives. You can see the knives are already a little bit bigger than they were when I started. As I continue playing, they're going to get really big. All right, now you can see the full screen. And you get to see the full screen where the knives are actually quite sized at this point. The catching mechanic is going to be like critical to the gameplay ultimately, because in order to be able to fire the knives off faster in the initial beginning, and also to self-correct if you fuck up the direction that you're firing a knife, you need to be able to catch it. We currently don't have that implemented, but it is definitely coming. Fun story about the initial discovery of the catching mechanic. I see the knives are getting real interesting now. This is all very performant. This is very smooth. Yeah, now the knife cooldown is just like so small that things are firing off very rapidly, and it almost has a 3D effect. That looks very cool. And we have a lot of stuff happening on the screen. We're able to wipe out all these bats with no problem and just collect all of that loot. And the more that we collect, the bigger, and at this point, the cooldown's as fast as it can get. But we can still make the knives much bigger. There's a couple little small collision tweaks that I need to make with regards to where the bats actually spawn and my ability to hit them. Because the knives are so big at this point, it's not really a problem. But in the very beginning, the knives are small enough that when you're on the very bottom of the screen, the knives may not necessarily make contact when you fire them with a bat that's coming at you. At this point, I think you get the picture of where the game is currently at and where we might go from here.